Welcome everybody, this is tutorial 3 and now in this video we're gonna be dealing with task 3, which is basically a repetition of task 2, the one that we did just a few moments ago. But in this task, what we are gonna use is just to know a little bit more about the heatx block itself. And now instead of specifying a heat duty as we did before, let's say that we don't want to use a heater before going directly to the heatx. This is of course possible, but then we don't know the heat duty a priori. So then we need to find another solution for that, and we just need to change the specification of the heatx block. And in task 3, they propose to us to just use as a specification the outlet temperature of the hot stream of the ethylene glycol to a target of 42 degrees. So now let's recall what we did in task 2. This was the result with the 4,781 kilograms per hour. But now, if we enter into the heatx, we will see that in a specification tab, we have many options. That's why the heatx is so versatile and is suitable for heat changer design. But now we're gonna select hot stream outlet temperature. And now we are gonna input the value of 42 degrees as expressed in the slide. And in principle, we should get the same result if the design spec was not active. Let's just deactivate it for just this purpose. And now let's open the control panel and go again. So no warnings, no errors. Now let's see the results that we get. And exactly we get the same ones. Because now the values of the design spec were inputted here. And now we get the same temperature. We get the 42 degrees. And let's see now the results that we get. We should obtain the same duty as previously calculated by the heater. And if you see, it changes slightly, but it is still within the tolerance of less than 5%, which is a good estimation. And you see that just by changing some specifications, you can get the same results. For a more comprehensive result summary, you can go to zones. And here you can have the summary of the most important parameters that were calculated. And you can also change the units if you wish. Let's say if we want to work with watts per square meter per Kelvin, like in SI units, you can see which U value is by default in the heatx block. Of course, you can change that in the future. Well, if you want, if you think that the U value is lower or higher, you can always go to the heatx input specifications, and then there is a tab that you can just click, is the U method, and now you can see if it's a constant U value or if your hot side is a liquid and cold side is a liquid and you don't want this value, you can always change it with the one that you might find in the literature and it should work. So this will give us a better estimation if we have a literature that can support it. So coming back to the results, let's go to the thermal results and now to the zones again. And now you can see that the duty was previously calculated. Now we have the mean logarithmic temperature difference also calculated. And now, well, the hot side specification, cold side specification, and now the area in square meters that we need to have for this heat exchanger to have the service completely done. And also the UA value, that is also important for heat exchanger applications. And you can see just by changing slight things like the hot temperature of the outlet of the stream, you can actually get the same results as if you were not using you were using the heater, and you get more information than in the heater block. So that's why the heatx is mostly recommended for your process designs, basically because you can get more data and you can get more information about how this process can be designed, and also how the equipment, in this case the heat exchanger, can be also scale up or it can be sized. So yeah, this is the information you can get from the HitX, and now we're gonna delve into a more rigorous model, just using the EDR function uh, available by Aspen One products. And well, with this one, we finished task 3, and I will see you then in task 4. Thank you for watching, and we'll see you soon. Bye bye.